Okay, so imagine building a city, but not with like concrete and steel,
Right.
but with microservices, containers, and Kubernetes.
Yeah,
It's a big project, right?
it is. Yeah.
That's kind of what we're talking about today, how Oracle Communications Billing and Revenue Management, or
Yeah.
BRM, um, takes on this challenge of cloud native deployments.
Yeah, it's a really fascinating evolution, and
Yeah.
you've provided us with some really excellent blueprints.
Yeah.
The Cloud Native Deployment Guide
Yeah.
and the Cloud Native System Administrator's Guide.
Yeah, they're dense.
They really are.
They're really dense.
Tacked with all the nuts and bolts of making BRM work seamlessly in the cloud.
Yeah, and I think our mission today is to kind of help people navigate these really detailed guides.
Yeah,
And so by the end of this deep dive, you'll have a really solid grasp of the core concepts, the essential tools, and the processes you need to know
right.
to make this transition a success.
Yeah, think of it as a shortcut to becoming a BRM Cloud Native expert.
Yeah.
So let's start by kind of painting a picture of what this Cloud Native city looks like.
Okay.
The BRM Cloud Native architecture, as shown in Figure 1 of the deployment guide,
Mm-hmm.
is built upon a foundation of microservices.
Okay.
And it's important to remember that security is paramount in this architecture.
Right.
All communication between these services is encrypted using TLS.
Right, because we're dealing with billing and revenue data.
Absolutely.
Very sensitive information.
Extremely sensitive.
Yeah.
And to further enhance security access is tightly controlled via Kubernetes service accounts.
Okay.
And robust authentication and authorization modules act as gatekeepers, making sure that only the right users and services
Right.
can access specific areas of the system.
Okay, so it's like layers of security checkpoints
Precisely.
throughout our cloud native city.
Exactly.
Yeah.
Now, within this architecture, we have three key players.
Okay.
First, we have the client applications, such as Pricing Design Center, Billing Care,
Mm-hmm.
Business Operations Center, and Pipeline Configuration Center.
Right.
They act like city planners,
Okay.
providing instructions and managing different aspects of our BRM city.
Okay, so they're like the brains of the operation.
They are.
Yeah.
And then there's the Connection Manager, or CM.
Okay.
This is where BRM's core business logic resides,
Okay.
processing information from the client applications
Okay.
and making sure everything runs according to plan.
Right.
Think of it as City Hall
Okay.
coordinating and executing all the plans.
Okay, so the client applications are like the strategists.
Yeah,
And the CM is the one putting the strategies into action.
that's a great way to put it.
Yeah.
And finally, we have the data managers, or DMs,
Okay.
responsible for storing and managing all the critical data generated by BRM.
Yeah.
They're like the city's archives,
Okay.
storing historical records, financial transactions, and everything in between.
Okay. It sounded like a well-organized city.
It is.
Yeah.
But to make this cloud-native city truly functional,
Yeah.
we need a robust infrastructure.
Right.
And that's where Kubernetes comes in.
Yeah. Kubernetes, or K8s,
Yeah.
seems to be mentioned everywhere in these guides.
It's everywhere.
It's like the bedrock of the whole system.
It's the foundation upon which our BRM city is built.
Okay.
Kubernetes orchestrates everything,
Mm-hmm.
managing the deployment, scaling, and operations
Right.
of all those microservices we just discussed.
Yeah.
Think of it as the city's infrastructure roads, power grids,
Mm-hmm.
water systems,
Yeah.
keeping everything connected and running smoothly.
So it's like the invisible force that keeps the city functioning.
Absolutely.
Yeah.
And within this Kubernetes ecosystem, there are a few key components that we need to understand.
Okay.
Let's start with persistent volumes, or PVs.
Okay, I've seen those in the guides in tables 2.3 and 2.4.
Right.
It seems like they're like the city's storage units, Like
Yeah.
providing space to store important data that needs to be accessed by various services.
Exactly. PVs are essentially pieces of storage made available to the Kubernetes cluster. They provide that crucial persistence for data that needs to survive.
Right.
Even if containers are restarted or moved around,
Mm-hmm.
think of them like the city's central database or a library,
Okay.
storing information that's vital for the city's operations.
So it's not just temporary storage, it's where the important stuff lives.
Exactly.
Yeah.
But how do different services within the city access this shared storage?
Right.
That's where persistent volume claims, or PVCs, come in.
Yeah. From what I've gathered, TVCs are like requests for a certain amount of storage space
Yeah.
from those PVs.
Mm-hmm.
So each container or service doesn't need to know the exact location of the storage,
Right.
just the resources that it requires.
You've got to think of it like this.
Okay.
A department in City Hall needs to store their archives.
Yeah.
They submit a PVC requesting, say, 10 terabytes of space.
Okay.
Kubernetes then finds a PV that can accommodate the request and connects it to the department's container.
Right.
Table 2.3 in the deployment guide actually provides some excellent examples of PVC names,
Okay.
giving you a sense of how they're used.
So the PVCs are like the paperwork for requesting storage space.
Yes.
And Kubernetes acts as the efficient administrator, fulfilling those requests and making sure everything is connected properly.
Precisely.
Okay.
And finally, we have services.
Okay.
They act as the communication channels within our city,
Right.
allowing different parts of the system to talk to each other.
Okay.
Think of them as the city's transportation system,
Right.
ensuring smooth movement of information and requests.
Yeah. And table 2.4 in the guide lists some specific examples of services,
It does.
including their names and types.
Okay.
Those examples will give you a clearer idea of how services are used
Okay.
in a real BRM cloud native environment.
Yeah.
Now let's talk about something that can make deploying this complex city a lot easier. Helm.
Okay. Helm sounds like a pretty powerful tool.
It is.
Yeah.
I'm eager to hear how it simplifies things.
Me too.
Helm is a package manager for Kubernetes
Yeah.
that helps you manage and deploy applications much more efficiently.
Right. Imagine trying to build our city by placing each individual brick by hand.
Okay.
That's what deploying without Helm would feel like.
Okay, so instead of laying bricks one by one,
Yeah.
Helm lets us assemble entire buildings from pre-designed blueprints.
Yeah.
Those blueprints being the Helm charts.
Exactly.
Got it.
Helm charts are packages
Yeah.
containing all the instructions and templates for deploying an application.
Okay.
They define the Kubernetes resources needed along with the necessary configurations, so
Yeah.
you don't have to write them all from scratch.
Yeah, that sounds incredibly helpful.
It is.
And the deployment guide even explains how to install Helm and where to download it.
It does, which is great.
Now, before we get too deep into deployment specifics,
Okay.
there's one more crucial component we need to talk about. The external provisioner.
The external provisioner?
Yeah.
I remember seeing that term in the
Okay.
guides, but I wasn't quite sure I grasped this purpose.
It's essential for managing persistent storage.
Remember those PVs we discussed earlier?
Yeah.
The ones that act like our city's storage units?
Mm-hmm.
Well, the external provisioner is the one responsible for actually creating them.
Ah, okay. So it's like the real estate developer.
Exactly.
You know, finding suitable locations and building those storage units for our city.
That's a great analogy.
Yeah.
And it needs to have what's called read-write-many access.
Read-write-many.
Yeah.
What does that mean?
It means that multiple departments can read from and write to the same storage space at the same time,
Okay.
just like a shared city library.
Okay.
This is crucial for BRM Cloud Native because many services often need to access and update the same data simultaneously.
Okay, that makes a lot of sense.
So it's not just about building the storage units, but also making sure they're accessible
Right.
to everyone who needs them.
What kind of data are we talking about here?
All kinds.
Okay.
Input data, like pricey XML files.
Okay.
Those are like the city's building codes.
Right.
Output data, like archive and reject files from the rated event loader and universal event loader.
Okay.
Imagine those as records of completed and rejected building permits.
Right.
And we also have shared data, like pin virtual time,
Okay.
which acts as the city's official clock,
Right.
ensuring everything is synchronized.
Yeah, so it's all the vital information needed to keep the city running smoothly.
Precisely. Now let's shift gears and talk about some of the configuration keys
Okay.
that fine-tune our BRM Cloud Native city.
Okay, configuration keys, these are like the settings and parameters that control how everything works.
They are, think of them as the control panel for our city's infrastructure.
Okay.
There are many configuration keys, but let's focus on a few particularly interesting ones.
Okay.
For instance, is upgrade and is Hoyle-enabled are used for managing SSL-enabled deployments and upgrades,
Right.
which is crucial for security, especially when updating our city's infrastructure.
Yeah, so these keys help make sure the city is secure,
Yeah,
especially during those moments when we're upgrading or making changes to the system.
precisely.
Yeah.
Then we have BDC cap log file size
Yeah.
and PD cap log file count.
Okay.
These are all about managing the city's logs.
Right.
The deployment guide mentions how these control log file rotation, ensuring that they don't grow indefinitely and take up valuable resources.
Right, so it's like making sure the city doesn't drown in paperwork.
Exactly.
Yeah.
And finally, we have Kirkajed DBC URL,
Okay.
which defines the connection details to the database used by Oracle Fusion middleware products.
Okay.
It's like the city's address book, providing the location of the central information hub
Right.
that all the city services need to access.
Okay, I'm starting to get a handle on these configuration keys.
Good.
They really are like the fine-tuning knobs that allow us to customize and control
Yeah,
how our BRM Cloud Native city operates.
that's a great way to put it to make things even more concrete.
Okay.
Let's look at an actual configuration snippet from the guide. The one provided for Oxybedia is a great example.
Okay, so this looks a bit intimidating at first glance.
It can be,
Uh,
but don't worry, we'll break it down step by step.
Okay.
First, we have labels with name and version.
Okay.
This emphasizes that version control is absolutely crucial
Yeah.
in the deployment process.
Right. We want to make sure we're building our city with the right set of blueprints.
We do.
Right. You don't want to accidentally use outdated plans or materials.
Absolutely.
Yeah.
Then we have settings like is enabled, deadline seconds, and revision hiss limit,
Okay.
which fine-tune how the deployment process behaves.
Okay.
It's like setting timers and limits for different construction phases.
Right. Okay.
And then we have image name and image tag.
Those seem pretty important.
These are very important.
Are these like specifying the types of materials we're using for construction and
Yes.
their specific versions?
We need to ensure we're using the correct materials for each part of our city.
Okay.
And finally, there's config-endiv, secret value, and service. These are related to configuring the environment for this component,
Right.
managing sensitive information like passwords,
Okay.
and defining how this component will be accessible within our city.
Okay. That's starting to make more sense now.
Good.
It's like looking at the detailed specifications
Isn't it?
for a building within our city.
Exactly. And speaking of security,
Yeah.
this snippet also highlights how important oath configuration is within our system.
Okay. Yeah, I've heard of that.
Mm-hmm.
It's all about secure access control, right?
Precisely, think of it as having security checkpoints throughout the city,
Right.
making sure only authorized personnel can access specific areas.
Okay.
The guide mentions a few key settings related to this,
Okay.
such as ocpdcrsm.configenv.inbound off front and jury, ocpdcrsm.configenv.inbound off proxy host, and ocpdcrsm.configenv.inbound off pub event scope.
All right. I won't pretend I understand all the details of that right now.
Yeah,
But it's clear that these settings play a crucial role
they do.
in keeping our cities secure.
You're right. They are the digital locks and keys
Yeah.
that ensure everything is protected.
Okay.
But OAuth is just one layer of security.
Okay.
We also need to consider SSO configuration.
SSO, that's single sign-on, right?
Yes,
It's like having one master key that can open multiple doors within the city.
exactly. SSO simplifies user access while maintaining security.
Okay.
The guide outlines the steps and keys involved in configuring SSO,
Right.
specifically mentioning the override.values.yaml file.
Okay.
This file seems to be where a lot of the customization for our deployment happens.
It does think of it as the master control panel.
Yeah.
Where we fine-tune the blueprint to
Right.
fit our specific needs.
Absolutely.
Yeah. And within this file, you'll encounter keys like ospb.wbfifi.config.env.so enabled, key store alias, and keys type.
Yes. These keys are all about managing security credentials
Okay.
and ensuring that they are stored securely.
Okay.
Key stores in particular act like the city vault, protecting those sensitive security keys.
So we're not just building a city.
Right.
We're making sure it's a secure one.
We are.
Now, I'm curious about the billing care REST API.
Okay.
Does it need any special configurations to work with BRM Cloud Native?
It does.
Okay.
The guide explains that we need to override certain keys
Okay.
within the values.yml file for both on-op job Helm chart and Austin Helm chart.
Okay.
We also need to set up what's called volume mounts,
Okay.
which act as dedicated communication lines
Okay.
between the billing care REST API and the rest of our cloud native city.
So it's like setting up a direct line
Exactly.
between the customer service department and the rest of the city.
Precisely. Now let's shift our focus to the Elastic Charging Engine,
Okay.
or ECE,
Okay.
and the key settings that govern its deployment.
Okay. The guide provides a table 10.1,
Right.
that lists these key settings.
Mhm.
One that caught my eye was image pull policy.
Yeah.
It sounds like it determines how ECE fetches its building instructions, so to speak.
You're right. Image pull policy controls whether ECE always downloads the latest instructions
Yeah.
or only when they've changed.
Right.
This helps us manage updates
Yeah.
and ensure consistency.
That's crucial. We don't want to accidentally upgrade a building
Right.
in the middle of construction.
Exactly. The guide also emphasizes the importance of disaster recovery and multi-cluster setup.
Right, which is crucial for any city as important as this one.
Absolutely.
Yeah, and the guide mentions a couple of key settings for this.
Yes.
SUREN and S service name.
Those settings are like having a backup city hall
Right.
ready to take over operations if the primary one goes down.
So it's all about ensuring that our city can withstand unexpected events.
Precisely.
Okay.
And we'll dive deeper into those disaster recovery strategies later on.
Right.
For now, let's move on to another key aspect of ECE CDR generation.
CDR, which stands for Call Detail Records, is like the city's record of transactions, right?
You're absolutely right.
Every phone call, data usage, and billable event is logged
Mm-hmm.
in these CDRs.
Yes, and ECE plays a vital role in generating these CDRs.
Okay.
It involves a few different components as outlined in the guide.
Let me see if I remember correctly. We have the HTTP gateway pod,
Yes.
the CDR gateway pod,
Yes.
the CDR formatter pod, and
Yep.
lastly, the CDR database.
Excellent memory. Those components work together to capture format and store all those billable events.
Right. And what's interesting is that the CDR gateway and CDR formatter pods can be scaled independently
They can.
to handle fluctuations in traffic.
Yeah, it's essential for any busy city
Right.
to be able to handle that rush hour traffic without things grinding to a halt.
Exactly.
And speaking of details,
Yeah.
the guide even mentions a document that provides a deep dive into the CDR format itself.
Oh, wow.
The ECE 5G CHF Protocol Implementation Conformance Statement.
Oh, great. So there's so much information packed into these guides.
There is.
And to make it even more real, let's look at another configuration snippet.
Okay.
The one for HTTP gateway and connection configurations.
Great idea. This snippet illustrates how the CDR generation process is configured in detail.
Okay. It's a lot to take in at first glance.
But we can break it down.
Okay.
First, we have settings like CDR generation enabled,
Right.
CDR generation standalone mode, rate offline CDRN real time, and generate CDRs for online requests.
Okay.
These control various aspects of how CDRs are generated.
So it's like setting the rules for how transactions are recorded in the city.
Precisely.
Yeah.
Then we have parameters like coherence member name, replicas,
Okay.
JVMG cops, and JVMPETs.
Those look a bit more technical.
They relate to memory management
Okay.
and how the HTTP gateway component operates behind the scenes.
So they keep things running smoothly,
They do.
but not something we necessarily need to worry about too much.
Exactly.
Got
And
it.
finally, there are a bunch of database connection settings.
Right.
Things like retry count, retry interval, maxep cache size, and others.
Okay.
These are all about ensuring reliable communication with the database.
Right.
Handling things like connection timeouts and retries.
Okay, so it's like having backup communication lines in case the primary one goes down.
Precisely. Now, moving on to a specific use case.
Good.
Let's talk about prepaid usage overage.
Okay.
The guide outlines how we can configure ECE to support this feature.
Prepaid usage overage, that's crucial for any city with residents using prepaid services.
It is.
And it seems like the first step is to make sure that ECE can communicate with our Kafka server.
Yes.
Kafka acts as the city's messaging system, right?
It does. And the guide emphasizes the importance of configuring ECE to specifically support prepaid usage overage.
Okay.
We also need to create an ECE overage topic in Kafka.
Right.
Think of it as a dedicated channel for overage notifications.
So it's like having a special alert system that notifies residents when they're approaching their usage limits.
Precisely.
Okay.
To make this happen, we need to configure some key settings in the override-values.yaml file. The guide mentions charging.kafka configurations, .kafka configuration list, charging.server.check, reservation over impact, and charging.kafka configurations.kafka configuration list, .overage topic name.
Okay, so those keys seem to control the connection to the Kafka server, enable overage checking,
Yes.
and define the name for the overage notification channel.
You're getting the hang of this.
Yeah, and it seems like a similar approach is used for recording failed usage requests.
It is.
Which makes sense.
Yeah.
Just like the city keeps records of unsuccessful building permit applications.
Right.
ECE needs to track those failed usage requests
That's
for
right.
troubleshooting and auditing purposes.
Exactly. And again, we need to ensure a connection to the Kafka server,
Right.
enable the recording of these failed requests,
True.
and create a dedicated Kafka topic for them.
Right.
The guide provides the relevant keys for this as well.
Okay, this is all starting to feel very organized.
Good.
And speaking of communication, the guide also talks about using Kafka for general ECE notifications.
Yes. It's like having a citywide announcement system for important events.
I like that analogy, yeah.
And setting this up is pretty straightforward.
Okay.
We need to make sure the Kafka and Zookeeper pods are running.
Okay.
These act like the central messaging hub and its caretakers, respectively.
Mm-hmm.
Then, of course, we configure some key settings.
Yeah.
Charging.server charging.kafkaconfigurations.hostname,
Right.
charging.server.kafkaconfigurations.hostname,
Okay.
and charging.server.kafkaconfigurations.topicname.
Okay, so those keys are all about establishing clear pathways
Yeah,
for different types of notifications within our city.
they are.
Okay, they control whether Kafka is used for notifications, specify the ECE cluster name,
Right.
the Kafka server's address, and the name for the general notification channel.
You got it. So it's all about setting up the infrastructure for seamless communication
Right.
within our BRM Cloud Native City.
Exactly. Now we've talked about how to build and configure our cloud native city. But what happens when things go wrong?
Right.
Even the most well-planned cities experience problems.
They do.
And I see that the deployment guide dedicates an entire chapter to troubleshooting,
It does.
which is reassuring.
Chapter 12 is our guide to navigating those inevitable challenges.
Okay.
One common issue mentioned is problems with Helm installation,
Okay.
especially timeout errors.
Helm timeout errors, what would that be like in our city analogy?
Imagine a traffic jam, preventing crucial construction materials from reaching a building site.
Yeah.
That's what a Helm timeout error feels like.
Right.
A frustrating delay that prevents things from moving forward.
Okay, I can see how that would be a problem.
Yeah.
The guide also mentions out-of-memory errors
Right.
during deployment.
Those are like running out of space in the city.
Right.
You can't build anything further until you free up some resources.
So we know what can go wrong, but how do we actually fix these problems?
The guide offers several helpful Kubernetes commands for troubleshooting. And one of the most basic but incredibly useful is kubectl get pods.
Right.
This command provides an overview of all the different pods running in our Kubernetes cluster.
So it's like having a bird's eye view of the city.
Yes.
Allowing us to see the status of all the different services.
Exactly. Especially when combined with options like OWIDE and BN namespace. We can get detailed information about each pod.
It's like having a citywide monitoring system that allows us to spot problems quickly.
Exactly. And if we want to zoom in on a specific problem area, we can use kubectl describe pod name-n namespace.
Okay, that's like dispatching an inspector.
Yes.
To get a detailed report on a specific building project.
Exactly. And sometimes we might need to revert to a previous state. For example, if a recent update caused problems, we can use the Helm rollback command to undo those changes.
So it's like having a rewind button for our city.
It is.
Allowing us to go back to a stable state.
Exactly. The guide mentions that the BRM Cloud Native System Administrator's Guide goes into more detail about this command, as well as the Helm uninstall command, which is like demolishing a building altogether.
Sometimes a fresh start is needed.
Sometimes it is. And if all else fails, we can always manually delete incorrectly installed Kubernetes resources. It's like bringing in a demolition crew to clear the site for a new start.
Let's hope it doesn't come to that.
I hope not.
Now, I want to talk about building BRM images. Chapter 12 of the deployment guide seems to delve deep into this process.
It does.
And it looks pretty involved.
It is. Building BRM images is like constructing the individual buildings that will make up our cloud native city. The guide emphasizes the importance of building images for various components.
Let me see if I can list them all. We have the BRM server, BRM REST Services Manager, PDC, PDC REST Services Manager, Pipeline Configuration Center, Billing Care, and Business Operations Center.
You got them all.
And
the guide is very specific about using the correct Docker build commands. And referencing the appropriate files and versions.
So it's like making sure we're using the correct blueprints and building codes
Precisely.
for each structure.
Yes, that's a lot to keep track of.
It is.
But the guide provides clear instructions to make things easier to understand. Let's focus on building the BRM server image as an example.
I'm ready.
The guide breaks down the process into several steps. First, we build images for each individual component. Think of it like constructing the different floors of a skyscraper.
So it's a modular approach.
It is.
Okay.
Then we build the Web Services Manager image.
Okay.
This is like setting up the building's communication systems.
Right.
Phones, internet, intercoms, allowing different parts of the building to communicate with each other.
Okay. Communication is key. What's next?
Next, we build the BRM REST Services Manager image. Think of this as installing the building's security and access control systems.
Right. Security is essential.
It is.
Especially in a complex building like this.
Right. And we can't forget about containerizing the email data manager, and the roaming pipeline.
Okay.
These are like the building's mailroom and transportation system, respectively.
Okay, so the mailroom handles all internal and external communication.
Yes.
And the transportation system ensures smooth movement of data throughout the building.
You've got it. And finally, we build and deploy Vertex Manager.
Okay.
Think of this as setting up the building's financial management system,
Okay.
responsible for tracking expenses, generating invoices, and managing budgets.
Okay, so we've constructed the main components of our BRM server building.
We have what's next on the agenda.
Yeah, what's next?
Let's zoom in on containerizing the Web Services Manager.
Okay.
The guide outlines two approaches,
Okay.
one for Tomcat and one for WebLogic Server.
So it's like choosing between two different elevator systems
I like that.
for our skyscraper.
For our skyscraper, Tomcat is the simpler option. Host speaker.
Okay, welcome back. We've laid the foundation for our BRM Cloud Native city.
We have?
And explored some of its key districts.
Yes.
Now let's shift our focus to making sure this city runs smoothly and efficiently.
Okay.
We're diving into the Cloud Native System Administrator's Guide.
All right.
To see what we can learn.
That's right. Building the city is just the first step.
Right.
Now we need to make sure it's well managed and secure.
Sounds like a big job. Where do we even start?
Well, let's start with the basics. Password management.
Okay.
Chapter 5 of the guide, Managing Passwords in BRM Cloud Native, is our roadmap.
Okay.
It might seem like a small detail,
Right.
but in a city filled with sensitive data,
Yeah.
strong password practices are absolutely crucial.
It's like making sure all the doors in City Hall have strong locks.
Exactly.
Yeah. I see the guide specifically mentions rotating the BRM root password.
That's right, and it emphasizes the importance of this practice. And it explains how changing the BRM root password affects all the clients that connect to the CM service.
Okay.
Things like Billing Care, the Billing Care REST API, Business Operations Center, and BRM Web Services.
Yeah.
They all need to be informed and receive the updated credentials.
So it's like changing the master key to City Hall.
Yeah.
Everyone who needs access needs a copy of the new key.
Precisely. And the guide provides a detailed procedure for changing the BRM root password
Okay.
and making sure all clients are updated. It even includes helpful tables that outline the key settings, involved pretty thorough.
It is now, besides the BRM root password,
Yeah.
the guide also mentions rotating the BRM root key.
Yes.
What's the difference?
Think of the BRM root key as the master encryption key for the city's most sensitive data.
Okay.
It needs to be rotated regularly to maintain a high level of security.
Right.
It's like changing the combination to the city vault,
Okay.
where the most valuable treasures are stored.
Okay, so we have the BRM root password for general access control and the BRM root key for protecting highly sensitive information.
You got it. And the guide outlines the steps for rotating both.
Okay, so we've got our passwords under control.
Yes.
What's next?
Let's talk about database partitioning.
Okay.
This might sound a bit technical,
Right.
but it's essentially about organizing the city's information more efficiently.
Okay.
Chapter 6 of the guide, Managing Your BRM Database, is our guide for this topic.
Database partitioning, is it like dividing the city into different districts or neighborhoods?
That's a great analogy.
Each with its own specific purpose.
Instead of having all the information jumbled together,
Yeah.
we create separate partitions within the database.
Right.
This can improve performance and make it easier to manage data.
Okay.
The guide mentions a feature that converts non-partitioned classes to partitioned classes,
Okay.
creating different types of partitions.
It seems like there are a few types. The guide mentions partition, migrate, daily partitions, and monthly partitions.
Right.
Can you explain the difference?
Sure. Partition migrate is a special partition
Okay.
that stores all the objects created before the conversion to a partition database.
Okay.
It's like the city's historical archives
Okay.
containing information that's important to preserve,
Right.
but not actively used in daily operations.
Mm-hmm.
The guide even mentions that the BRM purge utility, which removes old data,
Right.
can't touch objects in this partition.
So it's like a protected historical district.
Exactly.
Oh.
Then we have daily and monthly partitions,
Mhm.
which are created based on, well, the day and the month.
Right.
This makes it easier to manage data chronologically.
Yeah.
It's like having separate filing cabinets for each day or month.
Yeah, that makes sense. The guide also talks about adding new partitions to the database.
It does.
What's that like in our city analogy?
Think of it as expanding the city,
Okay.
creating new districts to accommodate growth.
Right.
The guide outlines a step-by-step process for doing this,
Okay.
which involves stopping specific BRM pods,
Mhm.
ensuring all running jobs are stopped,
Okay.
creating a restore point, like a city planning backup,
Yeah.
and finally using the partition utils utility to add the new partitions.
So it's like a carefully planned city expansion project, making sure we don't disrupt existing operations while adding new capacity.
Precisely. Now let's switch gears and talk about something crucial for any city performance.
Okay.
Chapter 7. Improving performance in BRM Cloud Native offers some valuable strategies.
Okay.
One approach is to run both DM Oracle and Centimeter in the same pod.
DM Oracle, that's the Oracle data manager.
Yes.
And Centimeter's the connection manager.
Uh-huh.
But why would running them in the same pod improve performance?
It's all about reducing communication overhead.
Okay.
Remember those services we discussed earlier?
Yeah.
How they're like the city's transportation system?
Right.
Well, when DM Oracle and Centimeter are in different pods,
Yeah.
it's like having City Hall and the city archives located miles apart.
Right.
Every time they need to exchange information, it involves a long commute. But when they're in the same pod, communication becomes much faster and more efficient.
So it's like putting City Hall and the archives in the same building.
Exactly.
Much more convenient.
Exactly. The guide provides a detailed example of how to merge these pods
Okay.
by modifying the dmoracle.yaml and cm.yaml files.
So it's like redrawing the city map to
Yeah.
place these crucial functions closer together.
Precisely. Now, another performance-related concept the guide discusses
Okay.
is connection pool tuning.
Connection pools. I'm not familiar with that term.
Imagine a busy train station with a long line of taxis waiting outside.
Okay.
When someone needs a ride, they can grab a taxi from the pool
Okay.
instead of waiting for one to arrive from somewhere else.
Right.
Connection pools work similarly.
Okay.
They provide a ready supply of database connections for applications to use,
Okay.
preventing delays caused by establishing a new connection each time.
So it's about having those connections ready to go.
Exactly.
Like taxis waiting at the station.
Precisely, the guide highlights 3 key parameters
Okay.
for tuning these connection pools.
Yeah.
Infranet.connectionpool.minsize,
Okay.
Infranet.connectionpool.maxsize, and Infranet.connectionpool.timeout.
So these parameters control the minimum and maximum number of taxis in our pool
Yes.
and how long an application is willing to wait for a free taxi.
That's a great way to put it. Now let's move on to another critical aspect of city management,
Okay.
high availability configurations.
Okay.
These are essential for ensuring that our city runs smoothly,
Right.
even if parts of it experience disruptions.
High availability, it's like having backup power generators
Nice.
for critical city services.
Yeah,
If one fails, the other one kicks in.
that's a good analogy. The guide focuses on deploying 2 specific components in high availability mode. UE Loader,
Okay.
which handles event processing, and the Payment Tech Data Manager, which processes payments.
So we're talking about 2 essential city services that
Yeah.
need to be operational 24/7.
Absolutely. And high availability is achieved through redundant deployments.
Okay.
It's like having duplicate bridges or tunnels
Right.
to ensure traffic can flow even if one route is blocked.
Okay, that makes sense. So far, we've covered password management,
Yes.
database partitioning, performance improvement,
Right.
and high availability configurations.
Correct.
Yeah.
What other challenges do we need to address?
Yeah.
Let's tackle multi-schema management, a concept that's essential for managing diverse data sets within our BRM Cloud Native city.
Multi-schema management, that sounds a bit complex.
It can be, but the guide does a good job of breaking it down.
Okay.
It outlines key tasks involved, such as running billing against a specific schema,
Okay.
adding new schemas, migrating accounts between schemas, modifying schema priorities and status,
Right.
and synchronizing something called uniqueness objects.
Wow, that's quite a list. Can you give me a simple explanation of what these tasks are all about?
Sure.
I'm not sure I understand the concept of schemas.
Think of schemas as different data districts within our city.
Okay.
Each schema might represent a different department, customer segment, or even a separate geographical region.
Right.
Multi-schema management is all about effectively managing these different data districts.
Okay, that makes more sense.
Yeah.
So it's like having separate databases for different parts of the city.
Exactly.
Yeah.
And those tasks you listed are about how we manage these schemas.
Okay.
For example, running billing against a specific schema
Right.
is like instructing the city's billing department
Okay.
to focus on invoices from a specific district.
Right.
Adding new schemas is like annexing new territories to the city.
Okay.
Migrating accounts between schemas is like moving residents from one district to another,
Right.
and so on.
So it's all about making sure the right data is in the right place.
Exactly.
And that everything is synchronized properly.
Precisely. Now let's talk about another important aspect of data management.
Okay.
Loading legacy data into the BRM Cloud Native database.
Legacy data, is that like incorporating historical records?
That's a great analogy.
From before the city was founded.
Legacy data refers to information from older systems
Right.
that we need to bring into our new cloud-native environment.
Okay.
It's a multi-step process
Okay.
involving importing the data into a staging area, recovering and reloading any failed processes,
Okay.
and finally deploying the data to the production area of the database.
So it's like carefully preserving and integrating historical documents into the city archives.
The guide highlights the tools used for this process.
Okay.
The PinCramp utility and the BRM app's job.
Okay, so we've covered password management, database partitioning, performance improvement,
Yes.
high availability configurations,
Right.
and multi-schema management.
Correct. It feels like we've addressed almost every aspect of managing our BRM Cloud Native city.
It does. What else is there?
Well, managing a city also involves keeping a close eye on things.
Right?
That brings us to monitoring, making sure everything is running smoothly and efficiently.
Monitor, that's like having a citywide surveillance system.
Exactly. And in BRM Cloud Native,
Yeah.
we have a few different tools at our disposal for monitoring.
Okay.
One of them is Perflib,
Okay.
which plays a crucial role in what's called opcode monitoring.
Opcode monitoring. What exactly are opcodes?
Think of opcodes as the basic instructions that drive BRM operations.
Okay.
They're like the individual tasks that city workers perform,
Right.
from processing payments to generating invoices to handling customer requests.
Okay.
Perflib allows us to track the performance of these opcodes.
So it's like having a time tracking system for all the city workers,
A perfect analogy.
allowing us to see how efficiently they're completing their tasks.
The guide explains that Perflib has a few dependencies,
Okay.
including the connection manager, the Oracle data manager, the synchronization queue data manager, and the account synchronization data manager.
So it's like Perflib gathers information from different departments
Exactly.
to get a complete picture of how the city is operating.
Precisely. And we can configure Perflib using environment variables
Okay.
in something called config maps.
Okay.
Think of config maps as setting up the rules for our time tracking system.
Right. Okay. So we can customize how Perflib tracks those opcodes.
The guide provides a table 10.1,
Right.
that lists and describes these various environment variables, so it's helpful.
Yeah. It is now, besides Perflib,
Yeah.
we can also leverage two popular open source monitoring tools,
We can?
Prometheus and Grafana.
Yes, I've heard of those.
Yeah, they're widely used for monitoring all sorts of systems.
Think of Prometheus as a network of sensors spread throughout the city,
Okay.
collecting data about everything that's happening.
Right.
And Grafana is like a central control panel
Okay.
where we can visualize and analyze that data in a meaningful way.
So Prometheus gathers the information.
Yes.
And Grafana helps us make sense of it.
Yeah, the guide mentions a few pre-built Grafana dashboards that we can use for monitoring BRM opcodes.
Right.
These dashboards provide real-time insights into the performance of different BRM components.
Okay.
We have one for the connection manager, one for the Oracle data manager, and one for the email data manager.
So it's like having dedicated monitoring screens for key areas of the city.
Precisely.
Okay, that's great.
It is now, besides monitoring BRM itself,
Yeah.
we also need to keep a watchful eye on those client applications we talked about earlier.
Right.
The guide dives into how to monitor the Business Operations Center, or BOC.
Okay, BOC, that's the city's central operations hub, right?
It is, and monitoring BOC involves a few different steps.
Okay.
We need to install Prometheus and Grafana,
Right.
configure something called the WebLogic Monitoring Exporter,
Okay.
set up the Prometheus webhook for auto-scaling,
Okay.
and choose between using standalone Prometheus or Prometheus Operator
Right.
for collecting data and sending alerts.
Wow, that sounds like a pretty comprehensive monitoring setup.
It is.
What's the purpose of the WebLogic monitoring exporter?
Well, BOC runs on WebLogic Server, which is a specific type of application server.
Okay.
The WebLogic Monitoring Exporter is specifically designed to collect data from WebLogic Server and make it available to Prometheus.
So it's like having specialized sensors that monitor the operations of the city's central hub.
That's a great way to put it. And Configuring this exporter involves enabling monitoring
Okay.
and specifying whether we're using standalone Prometheus or Prometheus operator.
So we need to tell the exporter how to communicate with the rest of the monitoring system.
Exactly. The guide emphasizes the use of the override-values.yml file.
Right.
And highlights key settings like queries, which define the specific data we want to collect.
Okay, so we can customize what the exporter monitors?
We can. And the guide also explains how to configure the Prometheus webhook for auto-scaling BOC pods.
Auto-scaling, what's that all about?
Imagine the city's central hub suddenly experiences a surge in activity. Maybe there's a major event happening.
Right.
Or there's a sudden spike in demand for city services.
Yeah.
Auto-scaling allows us to automatically increase the resources allocated to BOC to handle this increased load.
So it's like automatically adding more staff to the operations hub when things get busy.
And the Prometheus webhook acts as the trigger for this auto-scaling process.
Okay, that makes sense. The guide seems to provide a good explanation of how to configure the webhook.
It does.
Again, emphasizing the use of the override-values.yml file.
Exactly. And it even provides an example of how to configure the webhook for auto-scaling those BOC pods.
So far, so good. Now, the guide mentions both standalone Prometheus and Prometheus operator for collecting data from BOC.
Right.
What's the difference between these two options?
Think of standalone Prometheus as having a single monitoring station.
Okay.
While Prometheus operator is like having a distributed network of monitoring stations.
So it's about scale and complexity.
You've got the guide explains how to configure both approaches. And of course, we also need to configure Grafana to display all this data in a way that we can understand.
That makes sense. It's like designing the layout of the control panels in the city's monitoring center.
Now, we've talked about monitoring BOC, but what about billing care?
Right.
How do we monitor that?
That's a good question. The guide mentions that monitoring billing care and the billing care REST API is quite similar to monitoring BOC.
That's right. We follow similar steps, installing Prometheus and Grafana, configuring the WebLogic monitoring exporter.
Okay.
We need to do this separately for billing care and the billing care REST API.
Right.
And choosing between standalone Prometheus or Prometheus operator.
So it's like having separate monitoring systems for the customer service center and its online portal.
Exactly. And the guide emphasizes the importance of collecting data from both deployments.
Right. We need a complete picture of how both systems are performing.
Precisely. And the guide also explains how to configure the Prometheus webhook for auto-scaling billing care pods.
Okay.
Just like we did for BOC.
So if the customer service center gets overwhelmed with calls or online requests, we can automatically add more resources to handle the load.
You've got it. And the configuration is very similar to what we saw for BOC.
Okay.
Using the override-values.yaml file.
Okay, so far the monitoring setup seems pretty consistent across different BRM components.
And the guide also covers configuring standalone Prometheus and Prometheus operator for billing care.
Right.
Again, emphasizing the importance of collecting data from both the billing care deployment and the billing care REST API deployment.
So it's all about ensuring we have a comprehensive view of how everything is performing.
Now, the guide goes a step further and explains how we can deploy custom recording or alerting rules.
Custom rules? What are those?
Imagine we want to be alerted if the average wait time at the customer service center exceeds a certain threshold. Right.
Or maybe you want to be notified if the number of failed transactions reaches a critical level.
Yeah.
Custom rules allow us to define these specific conditions and trigger actions when they are met.
So it's like setting up custom alarms for specific events in the city?
Exactly. The guide provides an example of custom rules for automatically scaling up or down based on certain criteria.
So if the system detects a surge in activity, it can automatically allocate more resources.
It can?
And if things are quiet, it can scale back down to save resources.
You got it. And the guide explains how we use expressions and labels
to
define these custom rules.
Expressions and labels, those sound a bit technical.
They are, but the guide provides clear explanations and examples.
Okay.
It even gives us sample Prometheus expressions for triggering scale up and scale down alerts based on different metrics, like CPU and memory usage.
So we can set up very specific conditions.
We can.
For when to scale up or down.
Now, we've talked about monitoring BRM and its client applications. Right.
Using tools like Perflib, Prometheus, and Grafana.
Yeah.
But there's one more component we need to discuss. The BRM REST Services Manager.
Okay, what's special about monitoring BRM REST Services Manager?
Well, unlike BRM and the client applications,
Yeah.
which we monitor using traditional methods like collecting logs and metrics,
Right.
BRM REST Services Manager
Mm-hmm.
is monitored using a more modern approach.
Okay.
REST endpoints.
REST endpoints. I've heard that term before.
They're essentially URLs that allow us to interact with the BRM REST Services Manager
Okay.
using the HTTP protocol.
Okay.
The guide mentions 3 specific endpoints: health, metrics,
Okay.
and metrics application.
And these endpoints provide information about the health and performance of
Right.
the BRM REST Services Manager.
We got the health endpoint, for example, gives us a quick overview
Okay.
of the system's health,
Right.
including checks for things like deadlocks, disk space, and memory usage.
Yeah.
The guide even provides a sample JSON response from this endpoint.
So it's like getting a quick health report for the BRM REST Services Manager,
Exactly.
highlighting any potential problems.
And the metrics endpoints provide detailed metrics about the system's performance,
Right.
which we can then feed into our monitoring tools like Prometheus and Grafana.
Okay, so we have a way to monitor the health and performance
We do.
of BRM REST Services Manager. What else do we need to know?
Well, besides monitoring, we can also use tracing to gain deeper insights into how BRM REST Service Manager is handling API calls.
Right.
Think of tracing like having a GPS tracker for each API call,
Okay.
allowing us to follow its path and identify any bottlenecks or errors.
So we can see exactly what's happening to each API call as it travels through the system.
Exactly. And the guide explains how to set up tracing using a tool called Zipkin.
Zipkin. Okay, I'm guessing it integrates with BRM REST Services Manager somehow.
It does. Setting up tracing involves installing Zipkin,
Okay.
optionally securing the communication between BRM REST Services Manager and Zipkin,
All right.
and then enabling tracing itself.
Securing the communication, is that like encrypting the messages
That's a good analogy.
sent between the GPS tracker and the central monitoring system?
And the guide explains how to do this, including creating a client trust store
Okay.
for BRM REST Services Manager and setting the appropriate keys in the override-values.yaml file.
So we're protecting the communication channel
We are.
between BRM REST Services Manager and Zipkin.
Exactly. And enabling Zipkin tracing is as simple as setting a few keys in the override-values.yaml file.
Okay.
Is tracing enabled, Zipkin hostname, and Zipkin port.
So it's like flipping a switch to activate the GPS tracker.
You've got it. Now let's shift gears and talk about another important component, the Kafka Data Manager.
The Kafka Data Manager. Okay, I remember we talked about Kafka earlier, that it acts like the city's messaging system.
Right.
What does the Kafka Data Manager do?
The Kafka Data Manager plays a key role in interacting with the Java server,
Okay.
handling data streams coming from Kafka topics. It's like a specialized department that manages all incoming and outgoing messages
Okay.
related to specific topics.
So it ensures smooth and efficient communication between Kafka and the Java server.
Exactly. Configuring the Kafka Data Manager involves enabling it,
Okay.
providing the connection details for the Kafka brokers,
Right.
and specifying the number of threads to use for processing messages.
Okay, so we tell it where to find the Kafka brokers,
We do.
like providing the addresses of different post offices,
Yeah.
and then specify how many workers should be processing the mail.
That's a great way to think about it.
Yeah.
Now let's move on to another important aspect of our BRM Cloud Native City
Okay.
integration with BI Publisher.
BI Publisher. That's Oracle's reporting tool.
You got it. And the guide explains how to connect both Billing Care
Okay.
and BRM Cloud Native to BI Publisher.
Makes sense. We need a way to generate reports and analyze data from our city.
We do.
So how do we set up this connection?
For Billing Care, it's pretty straightforward.
Oh, wait.
We need to configure a couple of keys in the override values.yaml file. ocbc.bc.canfddnv.byurl
Okay.
and ocbc.canfddnv.byured.
And those keys probably provide the BI Publisher URL and the user ID for accessing it.
Exactly. And for BRM Cloud Native,
Okay.
we configure the relevant keys under ocbrm.brmaps.deployment.pinenvdocken
Okay.
in the same override.values.yaml file.
So it's all about providing the necessary credentials and connection details
Precisely.
to allow Billing Care and BRM to communicate with BI Publisher.
Now, you mentioned that we've covered almost everything
Right.
related to managing our BRM Cloud Native City.
Yeah.
While we've touched on many key aspects, there are still a few areas left to explore.
Okay, I'm ready.
Okay. Before we wrap up this part of our deep dive,
Okay.
let's briefly discuss deploying BRM Cloud Native to Oracle Cloud Infrastructure,
Okay.
or OCI.
OCO, that sounds familiar.
OCI is Oracle's cloud platform.
Right.
It's a comprehensive suite of cloud services that can host a wide range of applications,
Yeah.
including BRM Cloud Native.
Okay.
It's like choosing a prime location for our city,
Yeah.
a place with all the amenities and infrastructure we need.
So we've built our city, and now we're deciding where to place it
Exactly.
in the cloud landscape.
Deploying to OCI involves several steps outlined in the guide.
Okay.
We need to set up an OCI account, install and configure the OCI command line interface, CLI,
Okay.
install kubectl, download the kube config file,
Right.
and verify that we can access the cluster.
Okay. It sounds like a well-defined process.
It is.
It's like acquiring land, obtaining permits, and
Right.
connecting utilities for our newly built city.
That's a great way to put it. Now let's shift our focus back to PDC.
Okay.
The Pipeline Configuration Center, the city's planning department.
Right.
The guide dedicates a whole chapter to running PDC applications in a BRM Cloud Native environment, introducing two key utilities, import-export pricing and sync PDC.
Import-export pricing sounds self-explanatory.
Okay.
It's used for importing, exporting, displaying, deleting, or publishing
Yes.
those pricing and setup components that we discussed earlier. It's like having a dedicated team that manages the city's building codes and regulations.
That's a perfect analogy.
You know, making sure they're up to date and accessible to everyone.
And sync PDC ensures that any changes made to these components
Right.
are synchronized between BRM and PDC.
So if the planning department updates the building codes, those changes are automatically reflected in how BRM processes things.
Precisely. The guide provides examples of how to use import-export pricing
Okay.
to import components from files,
Right.
highlighting the Helm chart config script's lode.esh script that simplifies this process.
Okay, so we have tools to manage those building codes efficiently?
We do. The guide also explains how to configure import-export pricing
Right.
using the override-values.yaml file.
Okay.
There are a few keys mentioned, i.e. operation, i.e. component,
Okay.
i.e. file with their name, and extra KM lane args.
So those keys allow us to specify what operation we want to perform.
Right.
What component type we're working with.
Yes.
Where the data is located.
Uh-huh.
And any additional parameters we might need.
Exactly. It's like giving clear instructions
Yeah.
to the building code management team.
Okay, so we have our PDC applications running and configured.
We do.
But how do we monitor them?
Right.
Just like any other city department, the
Yeah.
planning department needs to be monitored
It does.
to ensure everything is working smoothly.
That's a great point. The guide discusses monitoring PDC in a cloud-native environment,
Okay.
focusing specifically on PDC REST Services Manager logs.
PDC REST Services Manager logs, what kind of information do they contain?
They log a variety of events,
Okay.
including when the service starts and stops, when
Yeah.
it interacts with other applications, any authorization and authentication requests,
Right.
and even those zipkin traces we discussed earlier.
So it's like having a crick. Welcome back to our deep dive into BRM Cloud Native. We built our city, secured it, set up a robust infrastructure, but a city isn't truly alive until its residents, start using its services.
Right, you're absolutely right. And in the world of BRM Cloud Native, those residents are the various applications and services that rely on BRM's functionality.
Right.
This brings us to the topic of administering ECE, Cloud Native Services.
ECE, the Elastic Charging Engine.
Yeah.
I remember we discussed its role in CDR generation and prepaid usage overage.
We did.
But what does administering it actually entail?
It involves a range of tasks, from running SDK jobs to configuring tracing to setting up secure communication channels.
Okay, sounds pretty involved. Where do we even begin?
Let's start with running SDK jobs. The guide explains that after deploying the ECE Helm chart, we can run specific SDK jobs by providing the appropriate parameters,
Right.
like job.sdk.name and job.sdk.command.
So these SDK jobs are like specialized tools for managing specific aspects of ECE.
They allow us to perform tasks like data migration, configuration updates, or even custom operations tailored to our specific needs.
Right.
The guide also emphasizes checking the logs to verify the outcome of these SDK jobs.
That makes sense. It's like checking the work orders
Exactly.
to make sure those specialized tasks were completed successfully.
Yeah, what other administrative tasks are there?
Yeah.
Well, security is always a top priority.
Right.
So the guide delves into enabling SSL communication for separate BRM and ECE clusters.
Okay. SSL, that's all about encrypting communication, right?
Latest.
Like making sure all messages sent between different parts of the city are protected from eavesdropping.
Precisely. And the guide explains how to configure a custom wallet for SSL communication.
Okay.
Setting the appropriate keys in the override-values.yaml file.
Right.
Such as the path to the custom wallet and the secret name.
Okay, so it's like giving each district in our city a secure communication channel.
Exactly.
Making sure their conversations remain private.
Now, another important administrative task is enabling subscriber-based tracing for ECE services.
Subscriber-based tracing, what's the benefit of that?
Imagine you have a resident in our BRM Cloud Native city who's experiencing problems with their services.
Okay.
Subscriber-based tracing allows us to track all the activities related to that specific subscriber.
Okay.
Making it much easier to identify and troubleshoot the issue.
Right. So it's all about pinpointing problems related to specific users.
You got it.
How do we enable this subscriber-based tracing?
The guide outlines the steps.
Okay.
Which involves setting specific keys in the override-YAML file for parameters like logmax subscribers and logmax subscriber sessions.
Okay.
We also need to update the charging settings.yaml config map for specific functions.
Okay. Those sound like technical details, but I'm getting the gist of it. We're basically telling the system to keep a close eye on specific subscribers.
You're right. And the guide goes into more detail about those parameters and how they control the tracing process. Now, besides tracing, we also need a way to monitor the internals of ECE.
Right.
And that's where JMX comes in.
JMX? What's that?
JMX stands for Java Management Extensions.
Okay.
It's a technology that allows us to monitor and manage Java applications.
Right.
And since ECE is built on Java, we can use JMX to peek under the hood.
Okay.
The guide explains how to create a JMX connection to ECE using a tool called JConsole.
JConsole, is that like a dashboard for monitoring Java applications?
Exactly. It provides real-time information about various aspects of the application, such as memory usage, thread activity, and even custom metrics.
So it's like having a live feed from the engine room.
It is.
Of our BRM Cloud Native city.
That's a great way to visualize it. Now, let's talk about coherence, a technology that plays a crucial role in ECE's distributed architecture.
Coherence, what does that do?
Coherence is a distributed caching and data grid platform.
Okay.
In simple terms, it helps different parts of the ECE system share data efficiently. Think of it as the city's high-speed communication network that connects various departments and services.
Yeah.
The guide highlights a few important considerations related to coherence.
Okay, so what should we be aware of when it comes to coherence?
First, we need to make sure the contract library is installed and functioning properly.
Okay.
Think of this as the traffic management system for our city's communication network.
Right.
Then we need to check for any IPTAbles rules that might be blocking coherence traffic.
IPTAbles, those are firewall rules, right?
They are.
It's like making sure the security checkpoints in our city aren't accidentally blocking legitimate traffic.
You got it. And lastly, we need to ensure the necessary ports are open on the firewall.
Right.
For both the ECE coherence cluster and the metric service.
Okay, so we're basically making sure the city's communication network is running smoothly.
We are. What else do we need to know about administering ECE?
Yeah.
Well, disaster recovery is always a critical consideration. And the guide discusses how to set up active disaster recovery for ECE.
Okay.
This involves having multiple active production sites that can seamlessly take over operations if one site experiences a failure.
So it's like having two identical cities, each capable of running independently.
Exactly. And the key to this active setup is coherence cache federation.
Cache federation, that sounds a bit technical.
It is, but think of it as having synchronized copies of the city's important data in both locations.
Okay.
If one city experiences a problem, the other city can immediately access the data it needs and continue operations without interruption.
Okay, so it's like having mirrored copies of the city's archives.
Exactly. How do we actually set up this active disaster recovery configuration?
Yeah, how do we do that?
The guide provides the steps, which involve modifying the override-values.yaml file to set cluster topology to active.
Okay.
We also need to configure the primary and secondary cluster settings, including service names and fully qualified domain names, FQDNs.
Okay, those sound like network settings.
They are. It's like assigning unique addresses and communication channels to each city.
Right. The guide also mentions adding customer group configurations and site configurations to the override values.yaml file.
Right. Those configurations define how customer groups and sites are mapped between the primary and secondary clusters.
Right.
It's like creating a directory that maps residents and businesses to their corresponding locations in each city.
So we're setting up a robust disaster recovery system.
Yes.
Ensuring that our BRM Cloud Native services remain operational even in the face of unexpected events.
Exactly. And speaking of ensuring smooth operations, the guide also discusses Kafka configuration for disaster recovery.
Okay.
Remember, Kafka is like the city's messaging system.
Yes.
And in an active disaster recovery setup.
Right.
We need to make sure that messages are replicated between the two sites.
Makes sense. We don't want important messages getting lost in transit between the two cities.
You're right. The guide explains how to achieve this message replication by setting up Kafka mirroring or using a shared Kafka cluster.
Okay. Mirroring or a shared cluster, are those the only options for Kafka disaster recovery?
They are the most common, but there might be other solutions. Depending on specific requirements and infrastructure.
So we need to choose the Kafka disaster recovery method that best fits our needs.
We do. Now, before we move on from ECE, let's touch upon a couple of advanced topics mentioned in the guide. Using third-party libraries and custom mediation specifications.
Third-party libraries and custom mediation specifications, those sound pretty technical.
They are, think of third-party libraries as pre-built modules that extend the functionality of ECE, adding features or integrations that aren't included out of the box. It's like having specialized contractors who can build unique structures within our city. And custom mediation specifications allow us to control how ECE processes messages, defining rules and actions based on specific events.
So it's like having a team of traffic controllers who manage the flow of messages throughout the city.
Exactly.
Okay, I'm getting the idea. We're talking about advanced customization options that allow us to tailor ECE to our specific needs.
Precisely. And the guide provides some basic information about these topics, directing us to the relevant documentation for more details.
Great. Now, I think we've covered pretty much everything related to ECE.
We have, what other areas of BRM Cloud Native administration should we explore? Let's shift our focus back to PDC. The Pipeline Configuration Center. We've already discussed how to run PDC applications and monitor them.
We have.
But the guide also provides some valuable information about managing PDC. Particularly when it comes to log files.
Log files, we've talked about those for other components.
We have.
What's special about managing log files for PDC?
Well, PDC applications can generate a lot of logs. And it's important to manage those logs effectively. To prevent them from consuming excessive disk space.
Makes sense.
The guide explains how to configure log file rotation for various PDC applications.
Log file rotation, that's like having a system that automatically archives old log files and creates new ones.
And the guide explains the configurable properties for log file rotation, including log level, log limit, log file count, and the option to persist log files.
So we can control how much log data is kept and for how long?
Precisely. The guide also provides a table 20:1 that lists the default log file rotation settings for various PDC applications, including the pricing server, import-export pricing, sync PDC, and RIBRE.
RIBRE, what are those?
RIBRE stands for Real-Time Rating Engine, and BRE stands for Batch Rating Engine. They're both involved in processing rating requests, which determine the cost of services based on various factors.
So they're like the city's accounting department.
That's a good analogy.
Calculating how much residents and businesses need to pay for the services they use.
Now, besides the default settings, the guide also provides examples of how to customize log file rotation for different PDC applications using the override-values.yaml file.
So we have a lot of flexibility in how we manage those log files.
We do. And that brings us to the end of our deep dive into BRM Cloud Native Deployment and Administration. We've covered a wide range of topics, from the initial deployment process to configuring essential components, to configuring essential components, to managing passwords, databases, performance, security, and disaster recovery.
It's been quite a journey. We've built our city, populated it with services, and established a system for keeping it running smoothly.
We have, and I hope this deep dive has equipped you with the knowledge and confidence to tackle your own BRM Cloud Native deployments.
I feel much better prepared now to embark on this journey. Thank you for guiding me through this complex landscape.
You're very welcome. And remember, The world of BRM Cloud Native is constantly evolving.
Right.
New technologies emerge, challenges arise, and best practices are constantly being refined.
So the learning never really ends.
Exactly.
Yeah.
Stay curious, explore, and don't hesitate to dive deep into the documentation and resources available to you.
Yeah.
And as always, if you encounter any roadblocks, the Oracle community is there to help you along the way.
Thanks again, and until next time, happy